Hello everyone, this is Wellington with PX5, and today I'll show you how to port PX5 RTOS to an STM32 Cortex-M microcontroller using STM32 Cube IDE. So in this video, I'll show you the porting process, then we'll be generating a basic project using STM32 Cube IDE, then we'll be modifying some files, testing, and then I'll share some resources. Let's take a quick look at what this porting process looks like. We'll start here with an STM32 Cube IDE base project. Then we'll add PX5 RTOS source files. Then we need to do some modifications on the startup file, linker file, and interrupt service routine file. Then we'll be adding one of the PX5 RTOS sample files, and then we'll test to see if it all works. In order to complete the porting, we need to change some files. Let's take a look at why do we need to do these changes. So first we need to do small modifications on the linker and the startup file. That's needed because PX5 RTOS elevates main to the first system thread, so we need the PSP stack to be there. After that, we need to change the ISR file. We'll be changing it to provide timer services by adding PX5 RTOS timer processing to the SysTick timer code generation. Still on the ISR file, since PX5 RTOS uses PendSV, we need to remove that from the ST generated code. Lastly, the main file. And PX5 RTOS sample defines main, so we need to change the ST generated main and remove the while one loop that don't worry about all of those details because we have prepared a porting guide document for the STM32 Cube IDE and you will find the link in the description below. Alright, so let's start with the demo. I have my STM32F769 and if you want to follow, the full name is F769i Disco. Alright, so before we get started, make sure to download your porting guide document, which is the PDF you can find in the description below. And with this, I will follow and I'll start with chapter 2, porting steps. Step number 1, generating the basic project using STM32 Cube IDE. Let's see that. Okay, so now I'm in the STM32 Cube IDE. I'll go to File, New, STM32 Project. Then I'll move to Board Selector. I'll type here 769, select the Discovery Board, which is the one I have, which is this one. Next, project needs a name. We can leave all of the options and hit Finish. Okay, now in order to generate a minimal version of this project, I'm gonna be removing most of the peripherals. So we'll go ahead and get this started and I will be following the sequence as set here under Pinout and the configuration tab. Okay, and with that I can hit Ctrl S. So after code generation, your project should look like this. Okay, so according to the guide, next step is to add PX5 RTOS source code. You can get that by downloading any of the samples. I already did that, so I have source code here. So I'll just take this, drag and drop, and release it on the root of this project, copy files and folders. Okay, so now I have the source code here. Next step, modify the linker file. And we have here what are the changes that are necessary. The first one is to add this to line 42. So let's do that. So back here to Cube IDE, I need to open the linker file. I'll go to line 42, which is this one, and I'll add this new line here. There's another change we need to do, which is replacing the user heap stack code with this one. So back to the linker file, we find the user heap stack section, and I'm gonna be replacing this with the code we have and save it. Next step is to modify the startup file. So now we're open the startup file, which is here under core startup, this one here, and it goes right at the beginning. So here, after the set stack pointer, let's paste this here, like so, and save. Going back to the guide, next step is to modify the ISR file. So let's open it. And the interrupt file is here under core source. That's the it.c file. And according to the guide, we need to add this function declaration before the sysdig handler function. So let's do that. So here under line 184, we find the sysdig handler. So I'm going to be adding that function declaration. And we also need to add a call to that function within the sysdig handler function. So let's go back here and add the function call to within the sysdig handler. And while we're here in the interrupt file, we now need to go here and just remove the pendsv handler function and also the svc handler. That's because PX5 RTOS also defines this, so we need to remove that from the STM generated code. Another file we don't need anymore is the syscalls.c, so we'll just go ahead and delete it. Okay, so moving on, we go back here in step 7, we need to add a PX5 RTOS example file. So let me find it. I have it here, which is the pthread create example. So just take it, go back to the workspace and add it to the source, copy file. And since this file we just added, the pthread create example already contains a main function, we need to remove that from the main.c that came with the st generated code. So I'll go here, find main, and we need to rename it. So looking at the guide, it says we should call it now void platform setup. So let me replace it here, like so. And also we don't need the while loop in here anymore. So I'm gonna delete it and save. So now finally on step 9, we need to modify the timer files. So let's go back there and open the how timebase tim.c. Go back here to the file and just copy these lines of code, which we'll be adding right following the how init tick function. Okay, now we can save it. Go back to the guide. There you go. Now all we need to do is to update project path and symbols. So let's go back, right click on the project name, select properties. Then we go into CC++ general, paths and symbols. Then we go here to source location. Then we need to add a folder for the source file for PX5 RTOS. Hit OK. We also need to go back here to includes and add. And here we're just typing source, hit OK, and apply. Then finally we need to go to CC++ build under settings, and then we're looking to the linker, MCU-GCC linker miscellaneous. And now we need to add the object files, because if you remember, by looking at the source code, we actually have 2 object files. So let me go ahead and add it. Yeah, the first one is PX5.0. Okay. And the next one, add from the workspace here under source. That is PX5 binding.0. So hit OK, apply and close, and that should be it. Now I have my STM32 board. I'm going to connect it to the computer. And we should be good to start debugging. So let me go ahead here and hit debug. Okay, now so we're in debugging mode. As you can see here, we're stopped at the platform setup. I already added 3 expressions here. One to monitor each of the counters. We have in this sample 3 threads. The first one is the child thread. The second one is priority thread. And then we have the main thread. main thread and child thread will be yielding to each other, and then every second we have the priority thread waking up and trying to do something and then sleeping for 1 second. So what we expect to see if we continue running this is a count of the seconds by this counter. So let's see if it works. All right, so 6 seconds, and then I have around 2.2 million executions of each, the child and the main thread. So it works. Okay, so with this demo, we show how to get a bare sample from STM32 Cube IDE and make it work with PX5 RTOS. But before deciding you need to go through this process, make sure to check our website under samples. We might already have a sample working for you. So that's all we have for today. If you want to learn more or how to get started, make sure to check our website at px5rtos.com. You can also email us with questions, comments, or request for a quote at info@px5rtos.com. Thank you for your interest.